Good evening. In tonight's lesson, you will learn how to represent a function using a table and how to write a linear equation in function form. Let's begin by looking at some vocabulary. A linear equation in two variables is an equation in which variables appear in separate terms and in neither variable contains an exponent other than 1. So let's write down some examples. One example would be y equals 3x plus 1. I have my x and my y are in two different terms, and both of them only have an exponent of 1. Another example, 5x equals y plus 2. My x and y are in different terms, plus they both only have an exponent of 1. 4 equals 5x minus 3y. X and y are on the same side, but that's okay because they're in different terms. And they both only have an exponent of 1. So now let's write down a non-example or two. So one non-example would be y equals x squared. And this is a non-example because x squared has an exponent of 2, which breaks one of the rules in our linear equation. Another one would be 7 equals 4xy. Hey, if you're looking, x and y are in the same term together. So this is not a linear function. They both have an exponent of 1, but they appear in the same term together. Next, we're going to talk about solutions of linear equations. These are ordered pairs that make an equation true. Remember, ordered pairs come in the form x, y, where x is our input and y is our output. So what we're going to do today is we're going to, given a function, we're going to find solutions that work for that function. Okay, so let's look at our first example. It says use a table of ordered pairs. Find 4 solutions to y equals 2x minus 1. Okay, since we don't have any restrictions on what x can be, we can choose anything we want from negative infinity all the way up to positive infinity. But we want to make it as easy as possible because tomorrow we're going to start graphing. And the smaller the numbers, the better when we start to graph. So I would suggest, just for now, using the numbers -1, 0, 1, and 2. Okay, so in this spot, this is like our function machine. So this is where I'm going to put my function. This is what's happening to my number. So when I plug x in, I'm multiplying it by 2 every time and then subtracting 1. Okay, so my first step, choose any convenient value for x. The second step is to substitute the values into x. So I'm going to plug in these numbers. So I have y equals 2 times -1 minus 1. And then I have y equals 2 times 0 minus 1. Y equals 2 times 1 minus 1. And y equals 2 times 2 minus 1. And then looking at step 3, it says simplify to find the y values. Well, now that I've substituted in my x, now I can just simply follow the order of operations to simplify. So 2 times -1 is -2, minus 1 is -3. 2 times 0 is 0, minus 1 is -1. 2 times 1 is 1, minus 1 is 1. And 2 times 2 is 4, minus 1 is 3. Okay? And so then step 4 says write the solutions as ordered pairs. And this will be especially helpful for tomorrow when we're graphing. So our first solution is -1, -3. Second solution is 0, -1, and then 1, 1, and then 2, 3. And these are 4 solutions to this function. Looking at number 2, says find 4 solutions to y equals 4 plus 3x. Well, first thing, let's write our x values. That's step 1. So once again, I'm going to use these same 4. -1, 0, 1, and 2. And then I want to write my function. But here is a hint. When you're rewriting your function, okay, should be y equals, and then make sure x comes first. Let's start that over. Your x term comes first. That will be easier when you are trying to follow the order of operations and simplify. And this will be easier when we start getting into slope-intercept form. It just makes a little bit more sense to have the x come first. Okay, so when I rewrite this, since they're both positive, I can just simply switch spots with them. So 3x plus 4. So 4 plus 3x and 3x plus 4 are the same thing. I just wanted to write it where my x came first. Okay, so now my step 2 is I'm going to substitute my values in. So I get y equals 3 times negative 1 plus 4. And then y equals 3 times 0 plus 4. Y equals 3 times 1 plus 4. And y equals 3 times 2 plus 4. Step 3, simplify to find the values. So 3 times negative 1 is negative 3 plus 4 is 1. 3 times 0 is 0 plus 4 is 4. 3 times 1 is 3 plus 4 is 7. And 3 times 2 is 6 plus 4 is 10. Now I'm on to step 4, writing my ordered pairs. So my first ordered pair is negative 1, 1, and then 0, 4, then 1, 7, and then 2, 10. Now it's important that you understand that we could have chosen any numbers that we wanted for x, but we're just going to make it simple for us. Okay, let's look at example 2. Solve an equation for y. Well, if you look at this equation right now, x and y are on the same side, and what we had up in example 1, we had it already solved for our output, so it was really easy just to plug in the input, do whatever needed to be done, and get the output. Well, now if I do that here, I'm going to have to plug in the input, and I'm going to have to do some other solving to get my output. Well, what's really nice is to just do that solving once. So then you can just always plug your input and then get your output out once you apply the rules. So that is solving for y, or we also call this function form. Okay, y equals. So I want to get y by itself, and this is the same rules that we've learned when we learned how to solve equations. So for example, if we had x plus 4 equals 7, I would get x by itself by subtracting 4, moving it over, x is equal to 3. Okay, so same rules apply here. I have x and y here. Well, I don't want the 8x anymore. I want to get rid of it completely on this side. So I have a positive 8x. So in order for me to completely get rid of it, I need to subtract 8x from both sides. Now here is where it gets a little tricky. Because now when I'm simplifying, the 8x and the 8x go away, and I'm just left with my y. And this is where the mistakes happen, because some people say, well, 20 minus 8x, well, that's 12x. Well, I can't do that because they are not like terms. Okay, I can't combine them. They are not like terms. So all you can do is write them down as two separate terms. But remember, we want to write the x first. And if you look here, I have a negative 8x, so I'm going to write that first. And my 20 is positive, so it's plus 20. You could have also written 20 minus 8x, and that would have been equivalent. But we want to try to write our x first. That will just be a lot more useful for us. Okay, so then once again, we're going to come up with our 4 values for x. So negative 1, 0, 1, and 2. Plug in our function in function form. Negative 8x plus 20. And then your y, we are going to find by substituting in our values. So go ahead and take a moment, pause the video, and I would like you to completely fill out this table. Okay, welcome back. Please check your table with mine. Make sure you have the same numbers. If you did not get one of the same numbers, make sure you go back and try that computation again, and then put a question mark if you need some help when you get into class tomorrow. Okay, moving on to example 2 here. It says, solve for y and then find 4 solutions. Well, once again, I have the x and the y on the same side. So I want it in function form, which means I need to get y by itself. Well, this one's a little bit different. If you look at the 2 of these questions, this y is positive and this y is negative. So that's going to add a little bit of a challenge for us. So the first thing is I need to, since that's negative, and we've learned how to do that before with our regular equations, so let's remind ourselves. So for example, if I had 5 minus x equals 9, okay, we would subtract 5 from both sides, and I would have to drop down that entire negative x. And then we learned that we could either divide both sides by -1, and so I get the opposite of 4, which is -4. Okay, so let's use this on our function. So I need to get this negative y by itself. So I need to subtract 3x on both sides, get rid of my 3x, and then my negative y comes down. And remember, I can't combine 10 and negative 3x because they're not like terms, and I always, always, always want to write my x first. So then I get negative 3x, and the 10 is positive, so it's plus 10. But I'm not in function form yet because I haven't solved for y. It's not all the way solved. Well, this is like having a -1 out front. So really what I could do is I could take this and I could divide this by a -1, and then my 2 negatives would cancel out. But then what I do to this side, I also have to do to this side, but I have to do it to every single term. So divide it by -1 and divide it by -1. So now my new function is y equals -3 and -1 will give me a positive 3x, and a positive 10 and a -1 will give me a -10. So my new function is y equals 3x minus 10. Okay, so we're going to use the values -1, 0, 1, and 2. And I would like you to plug these values in and fill out your table. Pause the video to do this, please. Okay, welcome back. Please take a moment to check your table and your output values in your ordered pairs. Make sure they line up. If they don't, go back, try it again, and then put a question mark if you need to go over it in class tomorrow. Okay, what I would like you to do is flip over your notes really quickly, and I just want to do maybe 1 or 2 more questions. If I have 3x minus y equals 7, okay, I want to solve for y, which means I want to subtract 3x on both sides, and then I get negative y equals, writing my x first, negative 3x plus 7. I'm not done because I have to get this negative away, so I divide both sides by -1, all the terms, and I end up with y equals -3 and -1 gives me a positive 3x, positive 7 divided by -1 gives me a -7. Okay, one more. -4x minus y equals 8. I need to add 4x, add 4x. I get -y equals 4x plus 8. Divide everything by -1, and I get y equals -4x minus 8. Okay, so take a look at that. Watch it again. And then answer those on your own questions on the back or on a separate line sheet of paper if you don't have any room. And then come to class prepared to go over these and answer any questions. Have a good day.